It's a fluid that is non-toxic, that evaporates and goes into gas, and then it condenses down.
Okay.
So there's a separation in terms of that.
So the hot water is used to
run the absorption cooling.
Okay.
It's really an old technology.
It's a heat expansion?
Well, yes, but it uses the gas like what the old refrigerator was, where you use natural gas to cool the, make ice and all that kind of stuff.
Right. Okay. You can show us that That's the high-tech stuff we're talking about. So, Willie, but beyond the fact that this is off-grid, what sticks with you as we walk here? I mean, are there any particular features you've seen?
Solar technology.
So the roof over here?
Yes. And the other part of this roof, the application that you're going to see a little later on.
Yeah.
That's really going to be fascinating.
Okay. So again, there's been a great effort to make this setting look as natural as possible and as conventional as possible, including a kitchen with ice boxes, freezers, refrigerator, all that.
And dishwasher.
Yeah.
So this is where the photovoltaic panels are located. 24 kilowatts on that roof, facing south and facing west.
So if we look at the roof of this structure we were just in,
and again it covers the roof so that it lengthens the lifespan of the roof, as well as providing another level of insulation.
Okay, so the whole roof over there is covered by the solar absorption panels.
Right, and it's on the other side also.
Okay, so the whole horizontal building is covered by solar. And then those are collecting photons.
Photons for electricity.
Right.
That's collecting
water
thermal energy.
Okay,
to
so
the water.
both being absorbing sun's rays.
Right.
But these are absorbing photons for direct electricity, and then this is for thermal conversion.
Heat conversion. That's right.
Okay.
And so, but when you look at the overall design, it's we call it the bioclimatic architecture.
Bioclimatic architecture.
Right. The whole idea of how the natural environment can fit into the design of a building.
Okay.
And when you look at the archway there, where you have pool on one side, in a hot summer day you have the airflow that creates.
So that's an architectural feature.
Yeah, that's an architectural feature.
Okay.
Along with
taking advantage of the breeze of the natural wind.
That's
flow.
right.
Okay.
And then the passive passive energy can be shaded by trees.
Okay.
And so you have trees on the side, and then the trellis.
Yep.
And so those are all.
So all the subtle features that, if you look closely, they're all revealing themselves.
Right.
Okay.
And there's no irrigation in this landscape.
No watering of these trees?
No.
The selection of the trees is all based on limited water?
Right. And so the first year was irrigated. But
so no automatic sprinklers?
No, no automatic sprinklers, and you don't have to worry about all that stuff.
Okay.
But water is going to be, like I said, very critical in our society. Here we're living in a desert, so everything is imported, and when you hear about the dangers that we're facing with the reduction of the water flow, I mean, it's really scary.
Sure.
And you can't live without water. So,
and population increase and decrease in water is going to be a bad combination. So, Willie, we're now, for a moment here, we're waiting for Les to get a key or access to where some of the hardware is here that's secure.
Right.
And you've got some observations while we're here for a moment.
Right.
What this has impressed you all the way through? You've been excited about this.
All the way through. A facility like this, I believe, should be located in every community throughout the country, just as an educational piece.
Right.
So, those community members and leaders can come in and actually see a building that's built off the grid in full operation.
Right. This is not a pipe dream, no pun intended. There's a little pipe dream there, right? Pipe dream for reality. But this is a functioning, breathing entity that shows that it's doable.
It's doable. It's not only doable, it's also needed. This is the future.
Yeah.
This is the future of building.
Yeah. You want to know about natural energy? Yeah. I'll tell you about natural energy. Give somebody a shovel and a rake and tell them to go to work.
Okay.
I'm kidding. I mean, there's no machinery there except human sweat and discipline, right?
Well, that might be anyway, what we have here, the inverters for the photovoltaic system.
This is the power station for this setting.
For the photovoltaic, yes, for this building here. This is called the inverter, and the inverter basically is really transitioning the DC power, direct current, from the photovoltaic to an AC power to run some of the AC systems in this building here.
So what's the production? It's not the same every day. What's the production variance? I mean, it can be as high as or as low as?
Well, right now there's 24 kilowatts, and if you do it times 6 or 7 hours a day during the summertime, that gives you an idea of the number of kilowatt hours that you have.
So 24 kilowatts an hour?
Yeah, it could be in terms of...
Okay. What's a typical household, 3-bedroom house need?
A typical probably maybe about 5 to 6 kilowatts.
So 24 kilowatts an hour is enough for an office building?
Right.
A small office building?
Small
like
office
this one?
building, yeah. And basically the other thing that you have to remember is that the idea of a storage battery system, which is very important.
Yeah.
Primarily, the batteries are in this facility here.
Yeah. And the solar power is being delivered into this junction box.
Yeah.
And then, is it coming in through here to these? It must be coming in from these into here,
yeah,
and then to the storage batteries.
And the storage batteries.
Okay.
Right. And so
that you're not pulling energy directly from the AC converters. You're pulling them from the storage batteries.
The storage battery.
Right.
And the real key for the battery technology, which is really the silver bullet of renewable energy, is that because everything is intermittent, solar provides during the peak times, at 12 noon, 2 hours before and 2 hours after, this is where 80% of the energy is collected, and the wind might blow at night and so forth. So the battery technology is really the future.
And specifically because of its ability to absorb, retain, and deliver a continuous available energy.
That's right. And there are technologies right now that you can use the free source first of solar energy before you use the grid energy.
Yeah.
And then if you don't have enough power, then the grid kicks in. So that's...
But your goal is to be off grid.
Yeah. The goal here is to be off grid.
Do you have capability to be on grid if you need to?
No.
Really?
No.
So you really have cut off the civilized world.
Yeah, right. Because the fact that, if I remember correctly, 24, I think the cost for bringing the power line from DWP network would have been $250,000.
Okay.
And
it's another deterrent.
Yeah, just to forget it.
Sure. Now these are all batteries.
Yeah,
these are what type of batteries?
These are, I think, lead-acid batteries. Batteries are coming out of the lithium-ion batteries.
Right, like laptops have.
Yeah, the laptop has.
Yeah. Expensive, but better.
Yeah, and longer life, lighter and smaller.
Now we get into this is some hardware. Now we're talking, here's the horsepower, right?
This thing right here is where the water systems are being evaluated.
What's being evaluated?
The process of the wastewater treatment. And
what's it evaluating?
In terms of the morbidity and all that.
You mean this is assessing the water for how many contaminants are in it?
Right, and so it's a process that they are looking at, and people are keeping track in terms of testing whether it's the ability to really use it for the flushing.
Well, I don't think you don't care about flushing as long as it's right. You're not drinking it.
Yeah, not drinking it, but there have to be some level of clarity.
Really?
So
but your system processes it out front of the building.
Right.
So the water gets processed, wastewater gets processed out there, and then shipped back over here.
Yeah. And the people from the city want to know just exactly how safe it is.
Is this experimental?
Yeah. Right now it's experimental.
Okay. But the goal, of course, is to be able to recycle.
Right.
So that covers the incoming electricity from the solar panels into the AC, converting direct current into alternating current, storage into the batteries here. We've looked then at a separate system, which is the water recycling. To what's next?
The next thing was the solar absorption cooling system. And this is a storage tank like a battery of 1,500 gallons of hot water that was stored. And then this is an absorption chiller that separates the lithium bromide through the heat from the gas, and then cools it down and comes back to liquid again.
So the gasification of the chemical is when the heat is absorbed as it's going through it becomes air conditioning. Am I getting that right? It becomes air conditioning by virtue of absorbing heat.
Right.
So you use the hot water to power this?
Yes, the thermal heat that separates the fluid called lithium bromide.
So it's the hot water that makes the lithium bromide go from a liquid to a gas?
To a gas, and then comes back down as a liquid again.
Okay, so you're circulating the lithium bromide as a liquid through the plumbing of the building. Is that correct?
Well,
or only here, the air
yeah,
gets so the air
cool
gets circulated.
Is circulated.
Okay.
Now, that's the cooling tower. And
over here?
Yeah.
So this is where the actual cooling of the air that's going through the building is going on. Okay. Pretty neat stuff.
Yeah.
Looks like a NASA rocket launch. Okay. High tech.
It's like a storage battery, you know.
Yeah,
for
that large
water.
container.
Yeah. Right.
So it's circulating water back up to the
Right.
roof. Now there must be an electric motor that pumps then.
Oh yeah.
Okay.
There's pumps.
Powered by the solar energy from over here.
And basically, in a compression chiller, it takes a lot of power to compress the energy to cool the place. This takes only about 1/10 of the energy because it's just pumping the water back and forth.
Yeah. I'm sorry, Willie, you were pointing out, what do you see here?
No, I was just saying, you had asked about the pumps,
Yeah.
and there are the controllers for the pumps there.
Okay, so here's what we're talking about then. Right? So there's a generator pump here, and a building pump, and the fan, which is right here. So these are all controlled by those panels.
Yeah.
But then can't get away from having to have the motors that pump. You still have the motors in the pumps. You need the energy for those. Okay.
And they added this power center also just in case of emergency to generate electricity with natural gas. That's another way of creating electricity if, say, it's totally dark for many
So you have natural gas access?
Yeah. That's where there's a storage on the top of the hill.
Yeah.
The propane.
See that tank, natural gas tank when you came in? Yeah.
No, but I was going to say that if you're really getting sophisticated, you'd have the waste management out there with its natural gas,
Yeah, right.
and you could power the building with natural gas from waste management. That's probably way out in the future. So then I take it they have field trips here from schools.
Yeah, you come here earlier during the day, you're going to see the busloads of kids from the various schools being bused here.
And inspired.
And inspired, yeah.
Yeah.
You know,
That's what it's about.
Natural parks.
So all day long, capturing every bit of solar energy right over there and turning it into thermal energy.